Yes, welcome back to Adson Engineering Academy. As I told you that earlier on, that we are doing a topic moment area method, and I explained for you the two theorem that moment area method dwells on. So I told you that I'm going to give you an illustrative example that will make you understand the concept much better. So please watch my first video on this topic so that you understand this one much better. So let's continue and solve this first problem. It's a simple one. So the question is given that we have a cantilever beam. From this cantilever beam, we are supposed to find the rotation at point A. By the way, this is point A and this is point what? Point B. Rotation at point B and also the deflection at point B. So since the first two theorem states that the first one says we need to find the area under the M by EI diagram. So if that is the case, you can use two things to prove it. I can draw, this is a cantilever, and the moment bending moment diagram in this case is going to be from this point. If you cut a beam from this side, that means at this point there is no moment. Moment here is 0, and then it will keep like this. So this is our bending moment diagram. So this bending moment diagram, P times this distance here becomes what? PL. Okay. So that means this is what our bending moment diagram. But if I divide this by EI, in this case we're considering EI to be constant. If I divide this by EI, I'm going to obtain M by EI diagram. So this is our M by what? M by EI what? Diagram. Alright? M by EI diagram. Just from the look of these things, if you find the area under this curve, you'll come out with what? The slope. But according to our theorem that we are derived, we say that if I draw the deflection of the elastic curve, and this is a cantilever. So for a cantilever, that means it will not deflect like this. Okay. It will deflect like this. Let's take another marker. Help me here. So from this point, if I draw the tangent, you see, you realize that this is our original A, then the tangent, this will be our tangent that we're calling tangent B. So this is tangent A, this is tangent B. So this difference between these 2 points is called tangent of B with respect to the original drawn from A. Now, the question wants us to find rotation. Okay, so that means at this point, with respect to this, if I draw this part here, is what I'm calling the change. Okay, this is the change, theta B minus theta what? Theta A. So our first theorem will help us to solve this first what? The first problem. Because what do we know? We stated in the first theorem that change in these 2 points is equivalent to the area, and this area was integral from what? Because this is 0, let's consider this as the origin from 0 to point L. So integral from 0 to L. Then what are we integrating? We are integrating what? The M by EI. Okay, so that means we're going to integrate here M by EI. Okay, but we're integrating with respect to what? We're integrating this with respect to x. So dx. If you take a section here, so this is x. So this is what we have. So according to the first theory. So from the first theorem, you just need to get your moment from this diagram or from the question given. Then you put it here, integrate, and you come out with the what? The slope. Now what do I know? Slope at point B. I don't know, I think the light is not clear there. So let me write it down here, okay? So theta B minus, since this is fixed, there is no rotation at that point. It's going to be equals to rotation from 0 to L. Now, if this is the origin, so if I want to find moment, it's going to be P times the distance, which is x. So my moment is going to be Px. But because it is downward in this case, according to what you consider, if this is y, this is x positive. Since it is downward, so this moment is going to be what? Negative. Then out of what? EI. Out of EI dx. This is the expression we have. And we have to integrate it to find the value of the slope at B. So the slope at B is going to be equals to, if I pull out this P by EI, right? And I will remain with integrate x. This becomes x squared. Alright? So from 0 to L. So slope at B is going to be equals to negative P, substitute this L square out of, remember, if you integrate this is x squared by what? By 2. Sorry. Okay? If you integrate this, the power becomes 2 and divide by that, so you get by 2. Correct that. And then out of 2 EI. So this is one way by using this integral, because it's a curve. Someone could also just get the area of this diagram directly, because the theorem says find the area of M by EI diagram, then you'll what? You'll get the slope. Okay, so since that was also the case, this is minus because P times this distance, but because P is downward, then it's a minus. Now if someone had not chosen that, then someone just decided to get the area. This is a triangle, so from this area of a triangle is half base height. So area is going to be half times, what is our base? Let's say the base is L, times what is this height? The height is negative PL by EI, right? So that means someone could also arrive to this answer. This is minus PL squared by 2 EI. Alright, because the theorem says like that. So, but the best way to go is this, because if the question is becoming more complex, you have to integrate so that you can get it easily, right? So, first part of the question is done. We have to do the second part of the question, that is what? The deflection. So, how do we get this deflection? Let me just erase this space. This is captured. I can erase this now. So we can do a second part of that question. The second part is asking for deflection. So how do I get the deflection? We said the deflection is, this is equivalent to the area which is already this times the centroid, right? Times the distance. So if that is the case, that means I will have to integrate from 0 to L, if that's what I'm considering, because the distance between these 2 points is L. Okay, 0 to L. Then I'm having M by EI dx, this multiply with what? Another x, right? That was our second what? Theorem. So from this second theorem, then write it here if somewhere is not being seen, please. From this second theorem, we shall obtain, first of all, what is our M? If I take a section here, M is going to be Px, but negative, so you don't have to forget that. So that means here is going to be 0 to L. M is negative Px out of EI. Then times, if I bring x here, this is x dx. Okay, this is x dx. So this is the expression I'm going to integrate so that I find the tangent of B with respect to what? To A, which is equivalent to the deflection at B, right? So this is equals to, if I integrate this, pull out P out of EI, so I will have to get, here is what? Here is x squared. So since here is x squared, so integrating from 0 to L, substitute I mean the limit from 0 to L, I am going to obtain, if you integrate x squared, here is supposed to be what? X cubed divided by what? By 3. So please, it's a simple integration, so you have to correct that. So this is going to therefore give us what? Minus P x, this x, if I substitute, is now L cubed out of what? 3 EI. So this is our tangent B with respect to A, which is just the same as the deflection at what? Deflection at P. So someone could also just go ahead and what? And use get the area under this slope, multiply with the centroid. The person will get the same answer. So I would like you to do that. Do that, get the area under this, which is already in our first question, multiply with the centroid. And that centroid should be with what? Respect to the what? Original axis drawn. Okay? So if you get that, you multiply with the centroid, you come to the same what? Answer. Okay? So in our next video, I will check that. You can give you what? You can try that whether you get the same answer. And see in the comment sections, you tell me what you have got, whether you've got the same or not. For now, let's end it here. Thank you so much. Don't forget to subscribe, watch the previous videos, and continue. We shall continue with this until you get every detail clearly. So thank you so much. See you in the next video.